Hello everyone and welcome back to session 5 of What Data Science Society's course, Beginner's Python. So we're over halfway through the course now and still plenty of exciting stuff to look at. In this session we're going to look at a new type of loop. So in session 3 we looked at this thing called a while loop, which allowed us to iterate running a piece of code until a certain condition stopped being true. And today we're going to look at a type of loop called a for loop, which is perhaps a more intuitive and more expressive way of looping through our code. So we're going to start off with a quick recap of the stuff we looked at last time. And if you're watching one of the hybrid live sessions, now is a chance to pop any questions in the chat if you want them to be addressed before we start. So last time we looked at list indexing and list slices, or just really everything to do with lists. And so there were two main points that we had to remember. I'm not going to go through the full details of everything we looked at, but two important things. The first is that indices start from 0. So whenever we're trying to extract an element from a list or taking a slice of a list, which creates kind of a sublist, the important thing is that the first element in our list has index of 0. So if we want, say, the third element of our list, that's going to have index of 2. So you've got to remember to take one off every time. And there's some beautiful mathematical reasons for why that is the case, but just something that you need to remember. And then the second important point was when we were taking slices. So an example of a slice here is we had this Prime Minister's list, and we wanted to take the 3 most recent ex-Prime Ministers. So that's the second, third, and fourth element. And so we have our offsets. We start from 1 because it's 0 indexed. But the important thing to remember is that the last index in a slice is not included. So if we want to go up to the fourth person, which is the third index, we have to go to an index of 4 because that last one doesn't get included. And the reason for this is so that the difference between these numbers tells us how many things we extracted, which is very useful, especially when we're using variables to define where our slices are. Maybe we had a slice going from n to n plus 3, where n is some variable number. Well, then it's easy to see that, oh, this is taking 3 things. And so that's the reason behind that. It's just something you have to remember. So a quick run through what we're going to look at today. It's all about this new type of loop called a for loop. So we're going to see how we can use this to loop through a sequence, so a range of numbers, say 1, 2, 3, 4, and also loop through all the elements inside of a list. And then we'll have a look at this thing called early stopping, so how, if we're doing a loop, can we stop things early, either skip a certain iteration and kind of go to the next one early, or stop the whole thing. And finally, we'll have a look at this thing called enumeration, which is a way of looping through an object, say a list, while also counting where we are as we go through. So with that, we'll pause for a moment if there's any questions in the hybrid live session, and we'll start off with today's content. Okay, let's get started with today's content then. So as mentioned before, today we're going to be looking at a new type of loop called a for loop. So 2 sessions ago, we introduced this idea of a while loop, but this is not the only type of loop available in Python. So we also have this for loop, and both of these are used for slightly different purposes. So a while loop is used when we want to run something until a condition stops being true. So we have a bit of code, and we want to keep running that for an undetermined number of times until some logical value changes whether it's true or not. A for loop, on the other hand, is meant for scenarios when we're running some code a predetermined number of times. So that could be we're either kind of repeating something, say 10 times, or it could be we're looping over, say, a list, every element in the list, and there's a predetermined number of elements in that list. So, in other words, we prefer a for loop over a while loop when it's possible to calculate how many times the loop is going to run. Now, we don't necessarily have to calculate how many times it's going to run. It could be the case that it's a fixed number of times, but calculating that is a pain to do, and that's fine. As long as theoretically we could calculate how long the for loop would run for, then the for loop is appropriate. And whenever we don't know when something's going to end, then a while loop is more appropriate. And so the syntax for a for loop looks something like this. We're going to start with a simple example where we're going to loop through a series of numbers. So we're going to kind of count up to a certain number using a for loop. And we're going to use a function called range, and this is used to create a range object. You can think of this as a range of numbers. And the most simplest way of using the range function is to put in a single number and that's going to generate a range from 0 up to 1 less than that number. So in this case, we use range 5 to create a range of numbers 0 up to, but not including, 5. So 0 up to 4. And then the syntax for a for loop is for, and then we create some variable. This can be called anything, in a certain kind of iterable object, so something that we can loop through. In this case, we're looping through the range of numbers 0 to 4. And this variable here is going to keep track of where we are in that loop. So the for loop is going to loop through each element in this range, so 0, 1, 2, 3, 4. And this variable here, which we've called counter variable, is going to be keeping track of where we are in that loop. So it's going to be assigned a value from this range one at a time. And then inside of this loop, this variable is available. And all we do here is print out the value of that variable. So the first time we run this loop, counter variable is going to be given a value of 0. That's the first element in that range. And so we print out 0. The second time, it's given a value of 1. We kind of iterate through that range. And so we print out 1. And we keep doing that till we get to 4, which is the final one because we don't include that last number there. And so we can call this counter variable anything we want. We just have to use the same name inside of here. But typically, programmers like very short names. We typically use the letter I. And then if we have to have for loops inside of for loops, we then go J, K, L, and carry on like that. And so it's worth noting that this for loop we wrote here could be written as a while loop. In fact, while loops are the most general type of loop, and any for loop can be converted into a while loop. So with these 2 lines of code for a for loop, we could rewrite that with 4 lines of code using a while loop. We'll create a variable called counter to keep track of where we are. It's going to have a value of 0 initially. And then we're going to keep looping while this counter is less than 5. We print out the counter and then increment it by 1. So we have this plus equal symbol here. This means counter is equal to counter plus 1. It's just a shorthand for that. And this is going to create the exact same output as we had before, but it's a more verbose way of doing it. There's a lot more lines of code here. It's not as clear what is happening. So a for loop is simply a much more kind of intuitive and expressive way of doing these loops when there's a fixed number of iterations. But do bear in mind you can always turn it into a while loop if you so wish. And so we looped through a range from 0 before, but the range function is quite flexible. It can also let us loop from one value up to another. And to do this, we simply put in 2 numbers separated by a comma into the range function. And this is going to loop from the first one up to, but not including, the second one. So this is very similar to list slices, where if we have the slice 2 to 6, it goes from 2 up to 5 because we don't include the last one. In the same way, a range 2 to 6 is going to go 2, 3, 4, 5 and not include that 6. And so here we use kind of a counter variable or an iterator variable called I, and we print that out each time and we get the values 2, 3, 4 and 5. That's all of the values in that range there. So with that, let's have a go at some puzzles, just applying that knowledge of for loops. Then we'll jump back in a second to look at these solutions. Okay, let's take a look at these solutions then. So the first puzzle asked us to print out the numbers from minus 5 to 5 inclusive. And so if we want to do that, we're going to need the range minus 5 to 6. And the reason for that, as we mentioned earlier, is the last number is not included. So here we have for I, that's just, the variable we're using could be any name here in the range minus 5 to 5. And then we print out that value I. And the next one was asking us to print out the squares of the first 10 numbers. And so for this, we're going to need some looping variable, say x, in the range 1 to 11. So we're going to start from 1. And then I want the first 10. And so I know the difference between these has to be 10. Therefore, we're going up to 11. And then we print out, and I just put this in a sentence here. You could just print out the squares if you wanted. X squared is, and then the square of x using this double asterisk here. Or you could have done x times x. Okay, so that's how we loop through a range. We can also loop through a list. This is actually probably the more common usage of for loops. And so the syntax is very similar to before. So we can create a list, for example, our shopping list, containing eggs, bacon, sausages, and spam. And then we're going to do a similar syntax for then some looping variable in whatever our list is. So whereas before we looped through a range of numbers, here we're looping through a list. And again, this counter variable can be called anything. But we typically want to call it something that is indicative of what items we're looping through. So here, a shopping list is made of items, and so it's for item in the shopping list. And then for each of these, items are going to take on the value of a different element of the shopping list each loop. And so we can print out don't forget to buy, followed by the item. And so the first time we're going to have don't forget to buy eggs, then we'll have bacon, sausages, and spam. We can now take a look at some puzzles involving looping through a list. And this first one's a bit more complicated than our normal puzzles, a bit more in depth. So I'm going to just take a moment to kind of explain what's going on here to kind of offer some motivation. So we can use the sum function. We saw that quite a few sessions ago to calculate the sum of the elements in a list. But let's suppose for a second that this doesn't exist. How could we calculate it in another way? Well, we could use the code that follows here. And this is following what's called a design pattern. A design pattern is kind of a common template of code used for solving a certain type of problem. And this here is known as the reduction design pattern. And so this can be used to calculate the sum of the elements in a list. And let's work through why this works. So we have our list of numbers here. And the way we're going to calculate the sum is by calculating the partial sums as we walk through the list. So we can think of the sum of the whole thing as the sum of the first three add the last one. Well, the sum of the first three is the sum of the first two plus the third one. And we keep going like that, building up the sum as we go. So we're going to start by considering the sum of no elements, which is going to be 0. We're going to start with 0, then we're going to keep adding the values on as we go. And so then we're going to loop through each element, so each n in these numbers. And each time we're going to take the running total and we're going to add on that current value. So this kind of running total represents what the sum is of the first n elements of the list. And so this is going to get built up over time. It's going to start with value 0, then 2. Then it's going to be the sum of the first 2, 6, sum of the first 3, 8, and then the whole sum 13. So we build it up a bit, bit by bit. And we could do a similar thing for calculating the product of the elements in a list. Because actually there isn't a function in Python, or in the default Python, for calculating the product of all elements in a list. And so what we're going to do, we're going to try and adapt this design pattern to work for a product. So we're going to pause for a moment, have a go at that and the other puzzle. We'll come back in a second to look at these solutions. Okay, so hopefully you've had a good shot at those. Let's now kind of look at the solution to this. So there's only a few modifications we have to make this first solution work for a product rather than a sum. And that is, the most obvious one is replacing this running total update. Rather than adding on n each time, we multiply by n. So this running total is going to keep track of the product of the first n elements. So it's going to be 2, then it's going to be 8, then it's going to be 16, then finally 80. And so each time we want to take the previous product, say 8 for the first 2, and times that by the next one, you get the product for, say, the first 3 in this case. So that's the first change we have to make. And the second one is to start off from 1. And the reason for this is that if we start off from 0, well, then we're going to be doing 0 times whatever, and we're always going to have 0. But if we use 1, after we times by the first element 2, we're going to get 2, which is the product of the first element. And therefore, 1 is the right one to start at, and we'll carry on calculating the products of each kind of sublist, building up to the whole list. And so this might seem very complicated. Design patterns tend to be quite confusing if you've never seen them before. But the idea is this sort of idea comes up quite often for a wide variety of problems. And so as you build familiarity with it, it'll become more intuitive as to why this works and how you can adapt existing reduction design products to solve the problem you're after. And so another thing to look at is the second question. So count how many positive values there are in a list. And to do that, we're going to need a list and a counter of how many positive items there are. And then we can loop through the list. And if each value is bigger than 0, well, but then we increase the count by 1. So this is just count equals count plus 1, a shorthand for that. And then by the end of this loop, this count is going to represent how many positive values there are, and so we can print that out. Okay, so now we're going to have a look at early stopping. So when we do a for loop, we're running it for kind of a predetermined number of times. But it may be the case we want to exit the loop early. And to do this, we use the word break, the keyword break. This also works for a while loop, but it's less common to use this for a while loop because we could just put that breaking condition as part of the while condition at the start. And so, for example, we might want to use a condition inside the for loop to trigger it stopping. So here we have a list of numbers, and we loop through each of these. And if the number is less than 0, then we print out a little error message saying a negative number was found, we're going to stop. And then we use this break keyword. And what that means is stop the whole loop and carry on from after the loop once all the indenting is finished. And so we're going to run through. We have 4. This is not less than 0, so we carry on and print out n. We go to the next iteration, 3, we print out 3. We then have -1. This triggers this condition. We print out a negative number was found, and we break the loop. So we stop the whole loop, and we never get on to 2 and 7. And so we're left with just this output here. A similar thing, which is a bit maybe of a less extreme option, is rather than exiting the whole loop, is just to skip that iteration. So to skip that iteration and go on to the next one. And we can do this by using the keyword continue. So that doesn't end the whole loop, just skips that iteration and goes on to the next one. So for example, we could have here the same list of numbers and the same kind of condition. But when n is less than 0, rather than stopping the whole thing, we say negative number found, skipping, and then we continue. So we go on to the next value in that list. And so in this case, we have 4, 3. Those print out normally. When we get to -1, we print out this message and then we continue, which means stop the current iteration of the loop and go back to the starter of the loop. So notice we don't print this n at the end because we continue, but then we do carry on with the rest of the loop. We haven't stopped the whole thing, so we do the 2 and 7 after, which print out as normal. So let's have a go at applying those to this puzzle here, then we'll join back again in a moment. Okay, let's take a look at the solutions then. So the goal of this puzzle is to loop through a list. We're going to print out all the values. If we see a 0 element, we just skip over it. And if we see a negative element, then we stop the whole thing. And there's many ways we could formulate this, but this is just one example. So we loop through each item in the list. If the item has the value of 0, then we continue. So we just skip over this and go to the next iteration. And if the item is less than 0, then we break and we stop the whole loop. And if neither of these are true, then we print out this item here, which is going to be the number. And so this is probably not the most elegant way to write this. There are perhaps simpler ways, but you know, this is one way of approaching it. You may have a different solution. So the final thing we're going to look at is enumeration. And this is a feature that is fairly exclusive to Python. A lot of languages don't have this. And it's a really handy feature for allowing us to loop through a list while keeping track of what index we're on at the same time. And so here is an example of it in use. We have our agendum for the day. So 4 different items in that. And then we want to print out today's schedule. We want to print out in a format where we have a numbered list. And so what we're going to do, we're going to loop through this list, but not just the list itself. We're going to wrap that in the enumerate function. So an enumerated form of this list. And if you don't know what the word enumerate means, it basically means to count. And so rather than just looping through each item in a list, when we loop through an enumerated list, we loop through both the index and the item at the same time. And so the item is going to take on the values of the items of the list, and the index will take on the values 0, 1, 2, and 3. And so in the first loop, index is going to be 0, and item is going to be meeting, which is the 0th index. Then what we can do, we can take index, add 1 to it, convert that to a string so we can concatenate it with a bracket, and then print out the item as well. The second iteration, index will have value of 1, and the item will be 1 on 1. And so we keep doing that, printing things out, and this allows us to kind of keep track of where we are in the list and what we're looking at the same time in a very simple way. And so let's have a look at these puzzles, and then we'll join back again to look at these solutions for those. Okay, so we'll wrap up today's sessions by looking at the solutions for these exercises. So the first one is to loop through a list and print out whether each element's value is greater than, less than, or equal to the corresponding index. So quite a simple exercise. We loop through, common notation is I and n in the enumerated list. So I is going to be the index, 0, 1, 2, 3, and then n is going to be the actual values, 1, -2, 2, and 5, respectively. And then we simply ask, is I less than n, is it equal to n, or otherwise, I must be bigger than n, and then print out the corresponding statement. And so the second one, kind of the more interesting puzzle, is printing out every other element of a list. And we can do this by enumerating the list and only printing out elements if the index is even. And so the first index is 0, so we'll print out the first, then the second index, and carry on like that. So the first, third, and fifth elements of the list, indices 0, 2, and 4. And so we simply loop through the enumerated version of the list with I and n, and we use this percentage symbol, meaning the remainder. So the remainder when I is divided by 2. That is 0 if and only if I is an even number. So if I is even, we print out n, and that's going to print out every other element of the list there. So with that, we'll end today's session, and I'll see you again next week.